In introductory physics, physicists generally keep track of quantities using two forms. The first being scalar quantities. Let's just talk about that for a moment. The key detail of a scalar quantity is that it has magnitude only. What that means is it has no direction associated with it. So some common examples of scalar quantities that you're familiar with is you have 10 fingers, or 10 toes, or 1 nose, or 2 eyes. The key detail there being that you just add up the number of items that you have, and that's it. You don't have 10 fingers directed to the left. You don't have 3 eyes directed upward. It's just a number that you count. So some examples in physics that you're going to see for this are going to be mass with units of kilograms, and eventually we'll encounter energy being kept with units of joules. All right. There are many, many more scalar quantities, but these are just a few examples. Okay, so this sets us up for what is the other method. Well, we keep track of quantities as vector quantities. And a good question is, why do we bother using vector quantities to keep track of physical parameters? Well, it's because the universe cares. Right? Sometimes it's just useful to define a quantity that has both a magnitude and a direction. What that means is it's some number of whatever our unit is that we're bookkeeping, and it's directed in a specific direction, and that direction is important. So whenever we're keeping track of a vector quantity, we have to keep track of two aspects of it: the magnitude of our quantity and where it's pointed. What are some examples of vector quantities? Well, velocity is one, and specifically why this is a vector quantity is because it's going to have some number of units. We can just make up 32 meters per second, but that 32 meters per second has to be directed in a specific direction. So the vector quantity has its magnitude of 32 meters per second, and its direction is going to be to the right or up or to the left. So when we're keeping track of vector quantities, we need both pieces of information in order for that quantity to be complete. Okay, so you may have noticed right here the symbol that I used for velocity has this little hat symbol above it. That's the symbol that is generally used for denoting that a quantity is a vector quantity. It's called a vector hat. And whenever you write out a vector quantity, you should include that little hat above it to indicate that. Okay, so let's just imagine that we have a vector, and say we want to represent this v right here. So let's just say we have 32 meters per second. Let's just stick with this to the right here. Okay, so how we could denote this is we could draw our vector to the right, and that would be the symbol that we would use, where the length of the vector, how long you draw the vector matters, is telling you the magnitude, and the direction of it is telling you the direction. It's incomplete without knowledge of both.